It's not a flat room. Okay, so here we go. Welcome to day one of Tech Ed. Of course, you probably heard that a few times already. Welcome to Tech Ed. Is there anybody in here who this is your first Tech Ed? Cool. Do you guys think it's all right? What do you think? You've been to 5 or 6 sessions already? If you haven't been to one of our Tech Ed conferences before, they can get pretty interesting. They can get kind of fun. I think overall, though, I think this is the biggest tech conference in New Zealand, isn't it? I think so. The only tech conference in New Zealand. Well, then I guess we qualify. Okay. People are still filtering in. That's all right. We've got about a minute to go. I think overall, we're going to do pretty well. You all followed the signs, right? Theater. I wanted to get a sticker and put security over the top of that. Call it security theater. Like airport security. There's some security theater for you. I travel quite a bit for what I do, and for some silly reason, every time I go through the little metal detector thing, I always get, excuse me, can you come over here? I want to check your bag. Every time with that crap. I say, you know, I'm a security consultant. I work in the industry. You go, yeah, that way you won't be giving us any trouble. Why don't you go after the bad guys? Somebody actually told me that once, that they said that if you look like you're ticked off when you go through those, they won't mess with you because they don't want any trouble. Like, that doesn't work in the U.S. That's when they want to nail you. All right, I think just about ready to go. That's good. So, anybody planning on moving to the cloud? Yeah? Some of you scared of it? Scared of moving to the cloud? It's big, isn't it? It's a big deal. In this session, I want to give you an idea of what you're going to have to think about when you start moving applications and data to the cloud. And I'll tell you a bit about how Azure protects your data and a few other things. Have any of you seen me do talks before? Seen me speak before? Oh, that's good. That means all my old jokes will still work. Doesn't make them funny. It just means I can tell them again. All right? So this is my stuff. This is me. In case you do want to send me an email, follow me on Twitter, read my blog. I spend more time flying than I do updating my blog recently, but that's par for the course. Oh, and before anybody asks, no, Steve is not here. No, Jesper is not here. They both work at Amazon now. So, okay. We're going to talk a bit about what we have to get ready for in the cloud. It's a mental shift. It's a change in the way you have to think about your applications and where your data is stored. We'll address some of the things like the questions you should be asking of your cloud service providers. What happens to my data when it gets to the cloud? What do they do with it? How is it stored? How is it protected, if it's protected at all? Okay? Use some feedback here. How Azure does some of the platform security, data center security, and what your expectations may be with your cloud providers, right? I don't subscribe to the idea that people should lower their expectations for the cloud. I think you should go in there with realistic expectations, which means there's some questions and planning you have to do first, right? These are the inevitable questions, okay? Give me a second to look at some of these. How do you ensure data isolation? Do you do data isolation? What about data retention and recovery? If you have a cloud application and that application deletes some data out of the cloud, how long are the bits physically in the drives? What do you do about it? A lot of people are concerned about the idea of data sovereignty. Funnily enough, it's more of a corporate policy than it is a law in most cases. There are some cases, especially in the EU, where data sovereignty is a law in some cases. But find out, right? Find out if you do have to deal with data sovereignty or not. You might not have to deal with it. And we'll talk about that in a second. I left HIPAA on this slide, even though HIPAA doesn't really apply here. You may still deal with PCI, FISMA, right? If you think about, does anybody here have to deal with PCI DSS? A couple of you? Okay. If you are what they call a credit card data on file merchant, which is a long way to say you store credit card information, you should comply with PCI DSS. At this red hot moment in time, there are no cloud providers that comply or have got the tick box for PCI DSS. Azure is in process of doing that, as are a couple others, but the PCI DSS wasn't written for a cloud scenario. So it's really difficult just to get a tick in that box. Okay? If you are not asking these questions, you're not serious enough about your cloud offerings and what you're going to do. You need to start asking these questions, especially if you work in anywhere that's got a regulatory compliance issue. For example, banking and finance, healthcare, state or federal government. Right? You need to be asking these questions. Okay? So where's the boundary? This boundary of control between what you have and what the cloud has. If you look at the far left side of the screen, right? Dedicated IT. This is what we're used to. A lot of us have been doing this. The bigger the organization, the more this you get. Some organizations outsource some stuff, in which case you get the second column from the left. Now, the more you send to a provider, the more responsibility they have and the less you have. But, do you trade the risks? Not usually. If you are collecting data on private citizens in Australia, New Zealand, well, pretty much anywhere in the civilized world, it's your duty to protect the data. If you make the decision to put that data in the cloud, and your cloud service provider is compromised or loses that data, it's you that they will come after. So you have to consider the weight of that. Now, if you look at infrastructure as a service, platform as a service, and software as a service, the last three columns, if you get to the far right, we're talking about things like Hotmail, BPOS, Business Productivity Online Services, all the stuff online, where actually the applications are online. The only thing you have in the cloud in those scenarios is your data. Okay? Some of you may have installed Office 2010. After the installation, it says, do you want to connect to the cloud? If you have Office 2010, you automatically get a license for the online versions. So you can work on your Word documents on your PC or from any internet-connected machine. Cool for convenience. Not so good for data proliferation, not so good for data protection. Right? If you look at this, though, software as a service has been around for over 15 years. We've been doing Hotmail for that long. That's an online email system. Right? If you don't like that much risk, you can back it down to where you do platform as a service, such as Azure, Google App Engine, or even further down, such as infrastructure as a service like Rackspace or Amazon, where you control everything from the virtual machine up. A lot of control, but a lot of responsibility. Now, sometimes smaller organizations like that. I'll give you all my stuff. I don't have to worry about it. I'll just worry about the data. Okay? Sorry. Thought I got rid of that. So, a lot of inhibitors to cloud computing. Number one, security. People have this idea that they can't trust a shared resource. We can't trust where our data is getting put in the cloud. Why not? How many of you in here have services that you expose on the internet? How many of you have business-to-business services exposed on the internet? You're using a shared resource, one that you have little to no control over, the internet. How many of you here use a bank? Do your businesses do banking transactions? You've outsourced your money management. I mean, they're actually holding your cash. Now, that's some trust. Of course, the first thing that comes to mind is what? Yeah, but banks have been doing this for eons. They've been handling people's money for eons, but they haven't been doing it with software very long at all. Yet, I'd be willing to bet most of us do online banking. Okay? It's not that much different. Why do you think people are willing to use online banking, but they're skeptical about the cloud services? Any guesses? The bank holds a lot of responsibility for the money. That's correct. That's one. It's an issue of trust, right? You trust that the bank has sorted out their security issues. That if something goes wrong, they're going to cover it. They have insurance to cover it. Okay? Now, all of this is in your SLAs with your bank, right? You need to look at similar SLAs with your data for your cloud provider. Some of them aren't up to snuff yet, but don't be afraid to ask that question. Okay? So there's these category pillars of stuff we think about cloud security. Security, privacy, reliability, and the business practices. Okay? In security, is the service secure? Does your provider have a track record of supplying online services? We've been supplying online services for over 15 years. People think we're new to the cloud, which is kind of ironic. If you go back to 2002, Bill Gates said that in one of his keynote speeches that Microsoft is investing in cloud computing and we are building cloud computing services. So we've been doing this for 8 years. That's actually longer than most other cloud service providers. Take that for what it's worth, you know. So, how about privacy? The 1972 Privacy Act is a reference to Australia. As you can tell by my accent, I'm from Canberra, Australia. So. How do you ensure data isolation? That's hard, isn't it? You put your data in a cloud, where does that stuff go? It does not just go to a drive in a rack in some bunker somewhere. Well, it might be a bunker. Normally with most cloud providers, in order to provide the kind of scalability they need, they take your data and they break it up into tiny bits and they spread it across many servers. And in some cases, many locations. It's my understanding that Amazon Web Services does that. They take your data, it is spread hither and yon, right? And then when you request it, it's put back together. It's a cool idea. If somebody does walk into an Amazon data center and rips out a drive, they get home, there's a bunch of fragment and pieces of stuff on there, but probably not any one thing that someone could put together, right? But who knows? Maybe the next time an application tries to access that data, it can't put it together either. Now, not that this is going to happen very often. We'll talk about data center security in a minute. Reliability. You ever had a service outage? Good question. When a certain teenage hacker attacked the core internet infrastructure, a few very major systems went offline, didn't they? Amazon, eBay, Yahoo, a couple others just vanished. Fortunately enough, we did not. Our stuff did not go offline. And there's a reason for that. If you look at all of the network service providers in the entire world, Microsoft is actually number 3 on that list for network service capability. That basically means we can handle more bits and have bigger network pipes than all except 2 other organizations in the world. Those 2 organizations are AT&T and the U.S. Department of Defense. We are the only cloud service provider on that list. Everybody else on that list is a telco. Well, except the Department of Defense. They're kind of their own telco in some weird ways. Right? Can they handle capacity? Will a distributed denial of service take your cloud stuff offline? Now, if you're using software as a service, that might be as simple as, I can't get to my online email. I can't get to my online documents. If you're using the cloud to provide your own services, your customers can't get to their services either. It's a denial of service attack on your organization on one side or the other. So you have to think about that as well. What's the capacity of your cloud service provider to handle things like DDoS? Okay? This last one, the business practices. Has the organization been around long enough, or have they been doing this long enough to have solid, stable, proven business practices? Patching, system maintenance. Do they have good relationships with providers to fix the hardware, to keep their systems running, to do data backups? Do they have disaster recovery processes? Most of the cloud service providers around today do. Right? It's not really a problem in most cases. If you've heard me talk before, I tend to try to not be too product specific. Obviously, in this talk, we're going to be talking about Amazon because I have more information. Sorry, Azure, because I have more information on that than other ones. And I think the Amazon story is good. The Google story is pretty good. And if you come to my talk tomorrow about federated identity in the cloud, I'll tell you how we've actually worked with these organizations to come up with some federated plans. But everybody realizes this is the next boom in IT. And a lot of them that can are investing very heavily in this. So chances are they're going to want to make sure they're going to get it right because they're betting the farm on it. We have to shift the way we think about these things. We haven't been doing this eggshell networking for quite some time. It's been 3 or 4 years now when we said we're getting rid of this. We're talking about deperimeterizing the network. Well, now not only have we deperimeterized the network with things like direct access, but we're even moving a lot of our core services into the cloud. The cloud is no longer something we go through, but something that we operate from. Right? That mind shift is going to change the way you handle your risk management strategies. If you're a risk-averse organization, like many financial and healthcare organizations are, then you may want to try to find a provider that will allow you to keep your data on site, but have your services in the cloud. So that when customers operate in those services, you still control your data. Especially if you have a data sovereignty issue. Okay? So that's one of the plans where you can ensure that your data is not going to get scattered hither and yon and be subject to somebody else's drive failure. Okay? Of course, a single drive failure is really not an issue anymore, is it? So, think about things like that we've had before. We've always had control over this idea of network access control lists and firewalls. Now they're pretty much just packet filters. They keep us from getting hammered internally. How many of you have had to set up a DMZ, even put an Active Directory setup in the DMZ to operate your services? You done that? If your service operates in the cloud, you don't have to do that anymore. At that point, people aren't coming into your network to get to your services. They're going to somebody else's network. So your internal corporate stuff that you keep on site will be less exposed if you can move some things into the cloud, especially your public offerings. Okay? Platform and network level encryption, it's still going to play a role, right? When you move stuff to and from the cloud, credentials, it's still going to be SSL. Okay? The developers are getting some increased responsibility here, though. One of the ways to deal with data sovereignty or to deal with critical data is to lower its classification level. Anybody here have experience with military organizations? Few of you. I didn't say active, I said have experience with. When you think about that, what do? Said, okay, we can handle a top secret document only in certain networks. But if we can make that top secret document a classified document, then we can put it on a bunch of networks. How do you do that? Encryption. If you take a top secret document and you encrypt it with modern cryptography, not just DES, but triple DES, AES, you lower its security classification level. It's now just classified. The key is, of course, remains top secret. You protect the keys, but you can take that encrypted document and it may now allow you to put it in the cloud. Okay. Now this may be a strategy you have to adopt. If you think about, and we'll get to who may have access to this data in a minute, but who has access to the data, where it's sitting, is it a data sovereignty issue? You can fix a lot of that by lowering the classification through encryption. Now, unfortunately, in some respects, this is still the realm of the developers. I say unfortunately, not because they can't do it, but because it means they've got more work to do and they have to do it correctly. If you look at the Azure Storage Service, it is not encrypted by default. In fact, none of the cloud providers right now encrypt data on the drive. There are applications that will do this for you. There's things like Dropbox, right? Dropbox will run it through AES before it sends it to the cloud for you. That's backed by Amazon Web Services. If you want to write one for Azure, by all means, go ahead. I thought about doing that, but that's another one of those long lists of projects I want to get to. So think about how your strategies for dealing with critical data. If it needs to go to the cloud, can you reduce its classification level? So some threats in the cloud. A lot of these will still exist. Okay? Right, so we talk about cross-site scripting. Look, if you write crappy code on-premise, it's going to be crappy in the cloud. If your code is subject to cross-site scripting or SQL injection, it's going to be the same problems in the cloud. So if that's an avenue to get your data exposed and compromised, that's not going to change. You have that problem in either situation. Some of the threats are expanded, like data privacy. I suppose when you talk about private data, there are ways, like we've just been talking about, where you might keep the private stuff on premise, the public stuff in the cloud, or use something like the Azure Service Bus that will let you collect data in the cloud, but actually sends it down to your private data center for storage. That's one of the patterns you can use to help protect that. There are some new threats: privilege escalation, jailbreaking, right, hyperjacking. The reason these exist is because almost all cloud providers are using some form of virtualization technology. Okay. Do any of you use virtualization now? A couple of you. Oh, quite a few of you. Good. So those aren't new. But if you're using virtualization technology, you have to deal with these threats already. Okay. Chances are, though, I mean, your developers are the ones creating these applications that it could jailbreak the VM or something. But you're familiar with them. So those don't really change in the cloud. If you don't have any virtualization experience, though, you have to start thinking about these kind of threats. Some of the old threats are mitigated. You don't have to patch anything anymore. And that's got to be worth something, right? Patch Tuesday doesn't affect you anymore. That's a good thing, right? And if you look at having to plan for failover and redundancy, you don't worry about that anymore either. Although, I gave this talk before in Australia, and somebody said, yeah, but does this mean we don't need a change control process, and can our developers just deploy directly to the cloud now? No. Do not abandon your change control processes. With all due respect to the developers, do not let them deploy directly to the cloud. Test it locally first. Right? If you look at Azure, you get two environments. You get staging and production. You can deploy into staging, use the GUID type URL to test it, and then you can promote it into production. But you should test it locally first. When the developers are happy with it, they can create the package, then let your change control team migrate it to the cloud. Okay, this does not mean you can abandon change control. We have this new operating model. If you look at the way this is designed, you go further you go to privacy, you get more control and governance, but you get less economy of scale. To some people, it may be a matter of necessity where they're going to have to go to the cloud.
to some of them, it just makes economic sense. Look at Department of Inland Revenue, or it's not Inland Revenue here, is it? It's just Department of Revenue? It was Department of Inland Revenue? Okay. So Department of Inland Revenue, they are busy a couple months out of the year. So they have to accommodate this spike in traffic. The rest of the year, 9 or 10 months out of the year, this massive server farm is sitting idle. It's taking up floor space. It might be taking up electricity unless they shut the servers down physically. All that goes away for the cloud. Now that's a huge benefit. But do you think DIR is going to put your data in the cloud? Probably not. So they have to find a hybrid solution. Okay. Process in the cloud, store data locally. And this is where our pieces fit. Jamie Sharp's going to be giving a talk where we'll talk about the Microsoft Global Foundation Services, which is the infrastructure that we build our stuff on. Windows, Azure, and Microsoft Online Services just go up the stack. Have any of you developed or deployed an Azure application yet? A couple of you? Were they experimental, or are you using it in anger? Experimental? We do have a lot of customers doing stuff in the cloud now. City of Miami, City of San Francisco, Domino's, Pizza Hut. So there's a lot of them doing it. The pizza thing is a great example, right? If you look at the pizza thing, they have all this infrastructure, but they don't need it very often. The time they need it is the hour before the NFL Super Bowl. That's when they need infrastructure. That's when they need power. So they go from like, and I don't know the exact number, there's like 20 instances. Then Super Bowl day, the hour before the Super Bowl, they ramp up to 1,000 instances. And then 3 hours later, they turn it off. They don't have to maintain any of that infrastructure. But their data is not private either, is it? It's an address that gets sent to a store, and it's not stored anywhere. Once the order is completed, that's gone. Right? Good example of where the criticality of the data is not important. So a cloud service makes a lot of sense. Okay? These are the ones that are, now we call them tenants, by the way. If you have an application that hosted in Azure, it's called a tenant. You get these defenses for free. So if you look at spoofing, we deal with VLANs and top-of-rack switches for you, so spoofing is very difficult. Port scanning, service enumeration, service definition files, Windows firewalls, you get all that for free. Tampering and disclosure. We have certificate services ready for you to use. If you want SSL communications between things, you can just turn it on. HTTPS, side channel protections. The denial of service, we're pretty good at that. We've got some really well-tuned stuff that helps us shunt denial of service attacks and control the traffic, in addition to our massive network pipes. Right, and elevation of privileges. A lot of that's restricted. VMs are sandboxed, they're run in least privilege mode. So you don't have to worry about too much of this anymore. You get all these kind of protections for free. Now, the responsibility for threat mitigation, okay? We talked about traditional servers already, and the additional ones in cases of the cloud. We handle some of the threats, but you're still going to have to deal with some of them on your own. Okay? So we'll take responsibility for these. Central administrator, custom admin, physical servers, users, and access to external websites. Basically, all the things associated with someone walking up to a server and fiddling with it go away for you. We deal with that. Our data centers are very secure. They're hardened. 24/7 monitoring, big thick walls, locks, multi-pass authentication, all that kind of stuff. Multi-pass. Sorry, Fifth Element. Sorry, that was a bad reference. Multi-pass. You have to be concerned about attacks against your provider, which will help you in choosing a provider and deciding what you're going to do. Right? So the provider has got to secure its facilities. Most of the big players have got this figured out. Right? Most of them decide, well, if the government's going to host stuff with us, we have to do X level of stuff. I don't know if any of them are doing per rack video yet. The data centers are on video camera, but for example, for a top secret server, you have to have a video camera on the server. Right? that doesn't make sense in the cloud. If you think about the data racks or the SANs or the storage area, your data could be spread across many of them at different times. So unless you got a camera that knows where the data is, it's kind of, you get seasick trying to watch that camera. So that doesn't make sense in a situation like the cloud. But the data center itself, the whole thing is on video. Right? We talk about customer tenants breaking out of their VMs. If we catch somebody doing this, they are terminated without notice. Terminate with extreme prejudice. Gone. Right? Not yet. We have seen instances where people have tried. They weren't able to break out of the VM. Fortunately enough, we knew that was happening because we told them to try it. Right? So we did a lot of testing around it. We actually, I think it was like 7 weeks, we put some pretty sharp hackers in there for about 7 weeks and said, go for it. Do whatever you can do. They couldn't come up with a way to do it. That's coming up. So he mentioned this one here, external websites. This happened to AWS. You may have heard in the news, someone set up a botnet in Amazon Web Services where it was used to send spam to other organizations. And if somebody tries to set up a VM that's going to just send all kinds of random crap out there to try to flood the network pipe for that section, that rack, we monitor the outgoing traffic. Incoming traffic is, other than the port filtering and all the stuff we do internally, the actual guts of it are up to you because it's specific to your application, and we don't really know what your application thinks is acceptable. But outgoing traffic, we monitor. Because if a VM goes rogue, or if a VM's been botted and it's starting to do nasty stuff, we need to know. And we'll help you troubleshoot that, right? If you do get a VM botted or something, and it wasn't your fault, except by accidental coding mistakes or something, we'll fix you up, right? We're not going to boot you for that. But if you intentionally set up a spam bot or something, we'll have the FBI meet you at the door. Does that answer your question? Kind of. Oh, right, like a black hole. Like the black hole dressing. So what if somebody sets up something on your VM that is spamming somebody and that gets you blacklisted? Right, it gets your service blacklisted or URL blacklisted. We'll help you rectify it if it wasn't your fault. Right? This can happen if you have a bad application. If you have a poorly written application and it gets attacked and taken over, and somebody installs like a bot on there, a spam bot or something, and then starts using it as a launch site, and your VM gets blacklisted or your domain gets blacklisted, we'll help you rectify that if we can see that it wasn't you doing it on purpose. Right? And almost all providers are going to do that. You know. If you're hosting WikiLeaks in America blacklist you? If you do that intentionally, if you host WikiLeaks intentionally, we can't stop that, because let's say you have some, with all due respect, some anti-Islamic stuff on there, and you get blacklisted from all the Islamic countries. That's their choice to not allow your traffic into their country. Right, so if one customer on a cloud gets blacklisted and the whole cloud gets blacklisted, that doesn't normally happen. It'll be done by URL and specific IP address. So we can usually avoid that through good DNS protection and stuff. I can tell you more details about it afterwards. We'll just chat about it for a minute. But there are things you can do about that. Right? What they usually do is they'll block the site, they'll block the URL instead of blocking the whole IP range. Yeah. We'll talk about that a little bit afterwards. Okay, so
Yeah, using a provider as a platform for attacking others, that's a big no-no, right? Good customers been botted will work with you. If it's a bad customer, you're doing it on purpose, can't handle that, right? You still have to worry about your customer, your administrators. The way Azure works, the way most of them work, you're given a set of credentials to upload new software, to check your data, to manipulate your data in the cloud. If someone inside your organization who has those credentials goes rogue on you and jacks up your system, we can't stop that. You have to protect those credentials. We can't stand there over your shoulder all the time saying, don't give that away. Don't write that on a sticky note. Okay, so you have to think about that. Nobody in here does the password on a sticky note thing, right? On the monitor? Okay. When I was coming in from the airport, and I had a whole conversation with the cab driver. Gave him the whole password rundown and taught him how to secure his computers. It was great. It's funny the questions you get in the cab. On your users, if your users attack your site, if your site was not written properly, you didn't pay attention to these earlier sessions, we can't help you with that either. If you don't write an application with good secure authorization and authentication in it, we can't fix that. It's up to you to fix it. We can sometimes help you troubleshoot things, but we can't fix it. Okay? Attacks in the deployment, that's a little different, isn't it? So it's like a physical server. Okay? If there's bugs in the code locally, there's going to be bugs in the code in the cloud. You're going to have the same problems. But like I said, we can look for symptoms, but you'll have to fix it. Now, I mentioned this earlier, abuse of privilege by your administrators. Apply the same control to your cloud administrators that you do to your local administrators. Don't give people access to data in the cloud that wouldn't have it locally. Okay? Now, it's a little harder to do side channel attacks, like someone open up SQL Server Management Studio and go to Azure SQL. That's a little more difficult, but not impossible if you give them the credentials. Okay, so protect those credentials. So there's a lot of layers to the Windows Azure security, right? I'm just going to make up a little time here and put this on the screen. The managed code access security is all in partial trust. That just starts from the center of it. So usually when an application goes up there, it's running in partial trust. It's not allowed to do a lot of stuff anyway, like operating system calls and things like that. Outside of that, the Windows account runs with least privilege. Now this account's designed so that if something does happen, and somebody does try to jack your application up, they can't do too much damage. Right? Stops at that a little bit. The Windows Firewall, virtual machines. Right? The virtual machines are set up to have fixed memory, fixed CPU, so even if they go rogue, they won't affect other virtual machines running on the similar infrastructure. Right? They can't do any damage, like resource starvation. Root partition packet filter, as well as network ACLs and dedicated VLANs. So there's many, many, many layers of protection in the Azure system to keep people in their sandbox. Okay? If we talk about handling attacks by a tenant, they really aren't dependent on the security of Windows. Instead, it's really about virtualization. And we talk about things like the drives, right? Drives aren't physical. If there's a C drive, it's not a physical drive. You can't fill up a C drive and knock the machine over. Then also is attack. They're virtualized. And the attack surface is minimized because we only accept a few commands. Even from a fully trusted assembly running on Azure, we only accept a few commands so that people can't try to get to data in memory or on physical disk of anybody else. Right? That keeps people from bouncing around too much, doing in-memory attacks. Okay? There are some cases where you're running, in some hosters, you can run multiple applications on the same server, shared infrastructure. If one of them goes rogue, gets hijacked, if that thing's running under a semi-privileged account that may be doing OS calls, whoever takes it over has the same privileges. They might be able to use the operating system to read your memory space. If you've recently did something, you may have a decryption key in that memory space. We stop that. They can't talk to each other, okay, except through the network service bus. The access control, you can still write your own access control in your applications if you want to. You might want to look into using the Azure ACS. I talk a bit about the ACS in my federated identity session tomorrow. You can mark data as world readable. So if you use a REST type web service, you can just read the data, right? Obviously, you need to be careful about that. Okay? Don't accidentally put protected data in a world readable location from like a REST web service. Okay? If you do want fine-grained access control, you can implement a pattern where you have a web role that accepts the requests. It only has storage access or access to a worker role. The worker role contains the keys to actually access the data. So there's nothing touching the web front end that actually has the keys to get to the data. So there's ways you can separate that. Okay. Now, Azure Storage, I got to speed up a little bit. For Windows Azure Storage in SQL Azure, it's like any other shared service. Okay, you have a storage account with credentials that you have to protect. The access policy is always enforced by code that parses that and satisfies the right conditions. For the compute stuff, you have a customer on VM that you pretty much get to work within. Your applications do just about anything in that they're allowed to do. Okay. Those VMs are isolated from each other, though. So if you're going to talk between VMs, you need to go through the proper bus structure and communication methods. They run on separate hardware with no network connectivity to compute, except logically through these HTTP channels. It's not like a named pipes thing, where you can't communicate through memory to these systems. They're separated from that to avoid attacks from jailbreaking. If I were you, I'd turn on SSL. I mean, why not? It's there for free. Unless you have a really performance-critical application, like down to the millisecond, turn on the SSL channel between your storage and your worker roles, web roles. It's always storage is organized into accounts. A single customer can have many storage accounts, and one secret key controls access to that account. So you could have multiple storage accounts with multiple secret keys if you need to keep a couple different things happening in your organization. Right? Different groups can have different secret keys for their storage data. Just because it's one storage account doesn't necessarily mean they're going to be sitting side by side on the disk. They may be separated. They may be spread out a bit. I was going to skip this slide, but there is need for locks on that. It doesn't deal with a conventional file system. We do have Azure File Storage, but it's actually backed by a database. So if you've played with Azure before, we've got blobs, queues, right, tables. Table storage is basically a big dictionary of name-value pairs, and the value can be anything. It can be objects. And we've got SQL Azure, which is for relational databases. File storage is coming. I mean, it's there, but it's not genuine file storage. It's kind of faked out. It operates like a file. Okay. You have to coordinate your own data access. We can't control two things happening at once in a table. Your code has to synchronize itself. Okay. We just provide access to the physical bits or the virtual bits like that. Data from many customers might be mixed into a single pool, but they're all isolated based on their accounts. So different storage accounts have a data isolation layer around them where just because they're physically close to each other doesn't mean you can get to them. Okay? Just like a SAN. Right? Storage keys can be randomly generated when the storage account is created. I strongly suggest you do that. Don't make your storage key some rinky-dink little thing that you're going to share across many places. Generate a new storage key each time. And the random number generator that does this is a true, strong crypto-random number generator. Okay? And all those storage keys are basically used to sign each request to your data. Now with SQL Azure, again, separate hardware. If you jailbreak a VM, you can't get out and start accessing data. It's not there. That data lives on a completely separate box. Through the developer portal, you can create your databases and passwords and set them to whatever you like. Okay. Your SQL administrator can create additional user accounts. Each of them will have its own password. You can set the privileges on each of those accounts. Okay. Reader, writer, all the different privileges you can have. While the data is pooled in a single instance, they are treated very much as separate things. even so far as think of them as separate tables, separate databases in a single instance. You guys have probably set up databases before, right, where you have one SQL instance that has many databases in it, and each database has its own access policies. It's similar to that. So the data is isolated pretty well. Data center security is free. These are world-class data centers. They're the no-holds-barred, government-level protected data centers. If you've ever had to deal with data center security and you've tried to set these things up, they can be a pain. You think about all the rules and laws and regulations, and all of a sudden, oh, we have a new application. We're going to store this kind of data. And it happens to be higher than classified. Your data center might not be up to scratch. So, 2-week, $10,000 project turns it into an $85 million data center upgrade. Right? Hopefully that only usually happens once. You get all this for free. You don't have to worry about that anymore. And that's one of the best parts about cloud security, right? Is that all the physical stuff goes away. You get all the industrial strength data centers you always wish you could have. And Jamie will show you a video about how we build the Generation 4 data centers and the trailers. It's pretty cool. Okay? Biometric controlled access systems. There's some pretty freaky stuff. I think it's not quite as good as the shuttle launch pads. In Cape Canaveral, I think the shuttle launch pads are the coolest things I've ever seen. Right? 2 fences, and there's nasty stuff between the fences. You go in a man trap, and there's a yellow box on the floor. You and everything you're carrying must fit in that box. And when you all fit in the box, the keypad comes on. You get a couple different codes, like a 4 and a 4+1. You say, this is my normal passcode, and this is the one I'm using when I'm under duress. Don't use that one. You get gassed, you're out. Air Force security comes up, pokes you with AR-15s, and take you away. And then once that happens, you do like a retina scan, and then the other door opens. Right? These data centers are like that. They're really getting to that level because they might have to store top secret data someday in the fairly near future. So you get all that kind of protection for free. I'll tell you a quick story when I was thinking about I did some emergency response stuff when I was working on Cape Canaveral, and you have to watch a security video. And the security video is, I say, don't step here or you'll get shot, kind of stuff. And they showed a video of a guy. He was running for the fence, running for the shuttle launch pad fence. And Air Force security come up out of little manholes in the ground. They grab him, throw him on the ground, and start trying to subdue him and handcuff him and all that. And this guy's fighting them. He is fighting for his life. And this is great. He's a really good actor. They're pushing him and shoving him and stepping on him and wrenching his arms behind his back and zip tying him. When they put him down, they put him in a fire ant's nest. The guy was fighting because he'd been bit from here to here by fire ants. That was funny later. It wasn't so funny when it happened. It was funny later. That was great. So the funny stuff, and you get to play with lightning generators. They have like a fire truck with a big boom on it. It's a huge Van de Graaff machine. They generate lightning and they shoot things like fuel storage tanks and towers. It's a cool place to work if you like to blow stuff up. So our data centers have been certified, right? We can store NASA's data. We have SAS 70 ISO 27001. The processes are SAS 70 certified. You follow the SAS stuff. The FISMA, Federal Information Security something standard. It's your data, but it's our job to protect that data. Okay? You need to hold your cloud providers accountable for this. A famous cloud provider recently said something like, well, SLAs and stuff are one thing, but you really should lower your expectations about the cloud. I don't think so. I just think you need to ask the right questions up front. Okay? Set your expectations with them as well as with you. If you don't read what their SLAs are, and you don't know what they can and cannot do, well, that's kind of your fault. Right? Check them out. Okay? Are they willing or able to make accommodations for your requirements?
Some of them can, some of them can't. Right? That this is the rack you get, that's all you get, go away. Or they say, here you go, here's your infrastructure as a service. You deal with the VM, we'll make sure that there's power and internet on there, but then we don't want to hear from you. See what level of support you can expect. Are there verifiable legal issues? Do you actually have a data sovereignty problem? You might think you do, because it's a common thing to jump to. We can't let our data out of the country. We did some checking back where I come from, and they found out that the law doesn't actually say that in most cases. In most cases, and I'm not a lawyer, in most cases the laws say that, well, the responsible party must protect the data. It doesn't say it can't be protected outside of the country. So if you've encrypted it, done all the right things to protect it, secured access to it, done your code reviews, you'll probably be okay. Show due diligence. Can you move the collection and process into the cloud and keep the data storage on site? So you might still be able to take advantage of all this massive data center stuff and power and scalability and free floor space. But just use the service bus to bring the data back home if you have to. And then, if all that fails, consider building a private cloud. Why not? It may be at this time that you don't trust or don't have the faith in the cloud service providers to handle your data. But it doesn't mean you can't start taking advantage of the rapid deployability and other things that cloud offers. We have a cloud appliance, the Azure Cloud Appliance. You can plug it into your rack in your data center, and it works just like Azure does. You might use other technologies to build one from scratch. Some scripts and some magic going on with hypervisors and things to make your own rapidly provisioned VMs. Okay? Consider doing that. What about open standards and known technology? One of the problems that often happens where data gets exposed is that people didn't think how it was going to be accessed. They thought, oh, we'll just build this system and off we go. Well, the problem is they get in there, they start writing this code, and they don't quite know how the code works, or they don't know the latest technology, so they wing it, and they end up writing a crappy application accidentally. Or they didn't use the proper procedures because they had to learn a new technology. Are there proprietary protocols? What if you have to learn and create a new protocol just to talk back and forth between your services? You're introducing change, you're introducing an unknown again. That's an area of instability. That instability can lead to a vulnerability, which can lead to data exposure. Right? What's the operation? What are the options for interop and portability? How well will your cloud service and your data interact with other cloud services, or other web service providers or consumers? What if I want to pick up and move cloud providers? Can I? What if I decide I don't like this and I want to bring it back home? Are you going to have to rewrite your applications in something you can run in-house? All of that introduces a lot of destabilization into your system. That introduces vulnerabilities, which gets data exposed. We're working on the interoperability standards for cloud computing. When you think about it, if you can move your cloud offering from provider to provider to provider, you have options, you have choice, right? You can go with whichever fits your system best. But if you have to learn new technologies to go from provider to provider, that's not so good. In the case of Azure, all of your developers that operate in .NET, nothing changes. You still write the app in C#, VB, whatever. You just deploy it in the cloud instead of locally. If you have to learn a new technology, which may be the case for the Google App Engine, for example, there's going to be a learning curve. You might have to reskill your developers. Not much, but there will be things you have to learn. So, in summary, right, there are a few new threats to cloud computing. Shared data, the idea of virtualizations and getting the virtual machines jacked up, jailbreaking. If you're running virtualization technologies already, these aren't that new to you. They're just a little bigger problem because of the potential.
right? I like that. You still carry all the application level threats. There is no service, there is no appliance, there is no plug-in firewall that you can ever get that will fix poor coding. All those things those guys are showing you today, if you went to those sessions, the hacking never stops ones. SQL injection, there's people out there bragging that their appliance and their equipment will stop all SQL injection attacks. That's not true. If the application is something that provides search, and people can do Boolean searches or do logic-based searches, that application must accept questionable characters in the search field. If that's the case, that appliance thing has to be allowed to send those questionable characters to the application. Only the application can defend itself. Only it knows what is acceptable and what is not. An appliance never will. The cloud never will. So cloud computing is not going to remove that problem from anybody. Okay? Pay attention to how well your vendor can meet your expectations. Don't assume it's going to be just like the data center we have in the backyard. Right? Find out what their levels are, their SLAs, and make sure that investment is transferable. If you're going to spend all this time moving to the cloud, make sure you don't get stuck. Do the ROI homework. Right? In a lot of cases, if you have high compute instances and you need to scale, or if there's a situation where you only use that capacity in short bursts, cloud computing is a very attractive option. Medium businesses that don't want to bother with maintaining their own infrastructure, their own team to do it, their own patching systems, that's a good one as well. Okay. And last one, have an exit strategy. No joke. I'm here to promote Azure and get you guys to move to the cloud and all that happy horse, all that stuff, but have an exit strategy. You may find that the cloud thing doesn't quite work for you, it's not quite ready for you yet. So, like, if you move to the cloud, don't get rid of all your hardware yet. Okay. Wait and find out. See how it's going to work. I wondered if I was going to get this within an hour, and I think I made it. So, we've got 5 minutes. We're supposed to tell you, I'll be in the recharge bar after the session if you have any questions. But, I mean, we got 5 minutes if you want to ask questions now. Yep. I can try. I think the technology will let me do that. Second or third slide where I had all the compliances. Not that one. This one? Or to which one? Down, down. That? Yep. So I don't see SAS on that slide. Oh, do you have a SAS.2 report? Right. That one. The SAS auditing process will examine your data center processes, how it's set up, how it's secured, and all that. And it'll give a report. And these are reports that providers should be able to give to potential customers. Right. Ask the provider, do you have one? Right. If they say no, say, are you going for SAS compliance? They may say yes, but we don't have it yet. If you want, Azure's got it. You can download our SAS report for Azure. Okay. Yep. Yes. In fact, I'll copy them right after this. It should be available minutes, I guess. Yep. Are we done recording? Jesper went to Amazon, to the best of my knowledge, because he wanted a slightly different day-to-day work life. Steve went to Amazon because I should ask him. Well, basically, Steve's over at Amazon doing the same thing he was doing for us, for them, except he's promoting Amazon Web Services instead of just security. Yeah, so as to your direct question, don't know.
Anything else? Oh, yeah. Yeah, I do. Well, me personally or Microsoft? Yes, we do. In fact, tomorrow my data center, or my federated identity talk, I talk about how we got together with like Google and Facebook and Yahoo and OAuth, and we came up with a new plan for federated identity in the cloud and stuff. And like I talk to Steve pretty regularly. Yeah, we keep in touch with all these people because there's some things that are industry problems, not company problems. And even though we compete, we still want to create this environment where all of you can expect similar things from us. Where uploading a VM is the same, communicating from service to service is the same. So yeah, we do talk to them quite a bit. Anybody else got a random question? Does anybody else have a planned question? Yeah. Oh no, I said HIPAA's not relevant in New Zealand because it's a U.S.-based standard, but it is still very relevant. The healthcare industry is all about HIPAA. Yeah, it's very relevant. I just don't think you have HIPAA here. It's a different kind of thing, isn't it? Yeah, so, yeah, healthcare data protection is still very relevant. Yeah. Yeah, and if you look at these kind of protection standards, HIPAA, Sarbanes-Oxley, Basel, PCI, man, they're a lot alike. They are really similar. But this guy can make money doing a PCI audit. This guy can make money doing a HIPAA audit. It's, but they're very, very similar. Yep. Is there any control over which country the data is stored in? There is to some extent, right? I wrote an Azure application to manage badges with a phone scanner for TechEd in Australia, and I said I wanted my data stored in the Singapore data center. Well, last time I forgot to mention it. It's a good thing you guys stayed late. When you talk about where your data is managed, you can geographically say I want it to stay here or here or here. Like Canada and China don't want the data in the U.S. because of the Patriot Act, so they move it out, right? Just because you say something like that in your data, you say I want my data stored in Singapore, for example, ask your provider where the data is backed up to for disaster recovery. The data center may be in Singapore, but it might be getting backed up to Hong Kong. Right? Now, there aren't too many cases where the data center is in, say, Texas and it's getting backed up to Beijing. Right? But ask them where your data is being backed up to as well. But in most cases, you can say, I want my data stored here. I don't think you can do that with Amazon, but you can with Google and Azure. Yeah, you can pay. I think you have to buy it that way. Okay. Okay. So yeah, I picked Singapore for mine because it's the closest data center to here, so I get better response times. Right, but I guess you said you can pay for Amazon to do that, to geolocate your data. Right, that is time. I need to get off the stage and let our next eloquent speaker come on stage, but I will actually go and hang out in that recharge bar if you have other questions. Thanks for coming.